Hello, this is Dr. Dave Gaitros, and I'm wanting to do a demonstration of state diagrams for my computer organization class, and I hope you find this handy. Here's the problem we have. It's very similar to one of the homework exercises without doing it exactly. Let's say that we're looking for a bit sequence, 0, 1, 0, and whenever we see this sequence, 0, 1, 0, when we see this last 0, we want to output a 1. Otherwise, we output a 0. Alright, well, if you look at the sequence of numbers up here, we can see that 0, 1, 0, there's a 1 right there, there's another sequence of them, and here we have some overlap sequences, which kind of shows you an example of where it can be kind of repetitive. Alright, well, what does that state diagram look like? Well, I can tell you that since we're looking for a sequence of 3 bits, that requires 4 states to actually accomplish that. So let's go ahead and put our bit sequence up here, 1, 0, so we can actually look for it. And now let's actually do that state diagram. Okay, and I'm going to draw the circles. There are 4 circles, and you can either do it in line or you can do them diagonal with one another. The pattern is not really important, and we'll go ahead and label them, and we'll say this is let me get a pen here, a red pen. We can make a little color. So this is state 0, 0. Oh, that one didn't work too well, does it? Alright, let's try this one. That's better. 0, 0. This was state 0, 1. This is 1, 0, and that's state 1, 1. Alright. So let's look at the sequence right here that we've got. What we want is, let's start in state 0, 0. State 0, 0 means we haven't got any input yet, or the pattern's been cleared and we want to start over. So I'm looking for what? Well, I'm looking for a 0. And whenever I see a 0, when x is equal to 0, okay, I transition to the next state. Okay, by being in this state, it says I've got 1, 0 ready. Now I'm looking for a 1. So I get a 1, I go to the next state. Okay, very good. So that means by being in this state 1, 0, I've got a 1. And now I go to this state, okay, when I get a 0. Okay, now by being in that state, I know I've got a 0, 1, and 0, and I can output a 1. All the other outputs are 0. Very good. Now all I've got to do is I've got to come up with the situations where it doesn't meet that criteria. In other words, I didn't get what I was expecting. It doesn't always go back to the beginning. Sometimes it does, sometimes it doesn't. Okay, for instance, let's say that I'm in state 0 right here, and I don't get a 0, I get a 1. What do I do? Well, as long as x is equal to 1, and I'm looking for that initial 0, I just stay right there. Okay. Now then, here I've gotten in state 2, I know what I do if I get a 1. What happens if I get a 0? Well, if I get a 0, I'm actually looking at a situation like this. I get 0, 0, 0. I've got a 0 and I'm waiting for the 1. And I don't go to the next state until I do it. So, as long as I get here and I get a 0, I stay right there. Okay? Okay, very good. Now then, this is the tricky one right here. This assumes I've got a 0 and a 1. Say, so I'm right here. What happens if I get another 1? Well, if I get another 1, that kind of destroys the pattern, and I got to start over. Okay, so that's x equal to 1. So now I've got everything except this last one. The last one's just a little tricky, because the last one I have to incorporate this situation right here, where I have 0, 1, 0, 1, 0, 1, 0. In other words, I can repeat myself. Okay, and that's done like this. When I'm sitting in this circle right here, I assume I've got a 0, 1, and 0. And what happens if I get another 1 again? Well, I can go right back to there, okay, and if I get another 0, it comes right back and I can produce another 1. So that's x equal 1. If I get a 0, it's like I'm starting right there from scratch again. So I can actually go to that, x equals 0. And that actually takes care of this sequence right here. What you want to do is you probably want to go through and do this a couple of times yourself and make sure that you can come up with this same diagram that I've done right here. Well, now let's look at the truth table for that. So let's say that we've got S1 right here and S0. That's our current state. That's where we're in right now. And X is input. And the output for that is the next state one, the next one we're going to go to. That's two numbers, and the output. Okay. Well, to do this, the very first thing you do is you've got 3 bits over here. That's going to be 8 numbers. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, and then 1, 1, 1. And then, of course, we want the corresponding numbers across here. So for each one of these, what we're going to do is we're going to go up to our state diagram, and we're just going to fill in the numbers. Okay, so here we're in state 0, 0, which is right there. We get an X of 0. What do? Well, we go to the next state, which is 0, 1, and we output a 0. Okay, we're in 0, 0, and we get a 1. What do? Well, we stay in 0, 0, and we output a 0. Now we're in 0, 1. I'm state 0, 1, and I output a 0. What do? Well, I stay in 0, 1, and I output a 0. You see this right here? Now if I get a 1, what do? Well, I go to the next state, which is 1, 0, and I output a 0. And if I'm in 1, 0, 1, 0, and I get a 0, then I go to state 1, 1, and I output a 1. See that? And if I'm in 1, 0, and I get a 0, what I have to do is I have to go back to the very beginning. Okay, or I get a 1, I have to go back to the very beginning and output a 0. I'm in 1, 1, and I get a 0. What do? I go back to 0, 1, output a 0. And if I'm in 1, 1, I go to get a 1, I go to 1, 0, and I output a 0. And that's our state table. And again, it's just following the paths. What state I'm in, what input I get, what circle does it go to, and what is the thing inside the circle. Very, very simple. Now let me do one equation for you. Assuming that you're doing something in Verilog, and you're doing something on a positive clock signal, so it only transitions to the next circle on a positive clock. Let's do the equation for O. Okay, so O is equal, excuse me, O is equal to a clock, okay, and I'll do the logic equation for it. And it turns 1 only whenever the clock is positive and you have S1 and you have S0 naught and X naught. And that's the equation for O. And what you want to do is you want to do the sum of products for each one of those. For instance, N1, the next state, the first digit of the next state is 1 whenever S1 naught, S0 and X, or S1, S0 naught, X naught, or S1, S0 and X. Okay. Well, I hope this helps you. I enjoyed doing it. Like doing these for you, and look forward to this video going viral. Talk to you later. Dr. Dave Gaitros out.